The world of computers is changing rapidly, but not always in ways that benefit the user. Every year, mainstream operating systems become heavier, demand more system resources, and collect more personal data from the people who use them. Within this environment, a different philosophy exists, one that prioritizes digital privacy, user control, and hardware longevity. PureOS is built entirely on this alternative philosophy. It is a completely free operating system recognized by the Free Software Foundation, designed to give you absolute control over your digital life without hidden tracking or forced corporate dependencies. The moment that many within the open source community have anticipated has officially arrived. PureOS Crimson has completed its long development phase and is now officially released to the public. For those who are new to the Linux operating system, a major release like this is a significant milestone. Think of an operating system as the foundation of a house. Over time, as technology changes, that foundation needs to be modernized to handle new tasks, secure against modern threats, and support newer applications. PureOS Crimson is a complete modernization of that foundation. It upgrades the core components of the system to ensure that your computer remains fast, secure, and reliable for daily use. If you are already running the previous version of this software, known as Byzantium, the transition path has been carefully structured to prevent friction or data loss. You do not need to wipe your computer or reinstall your applications from scratch. The development team has engineered a dedicated utility named the PureOS Upgrade application. This tool will arrive on your computer through your normal everyday software updates. Once it arrives, it handles the system transition safely in the background, verifying your files and updating your programs automatically. For users who are entirely new to the ecosystem and want to start fresh, official installation files are now available for standard desktop computers, laptops, enterprise servers, and specialized mobile platforms like the Librem 11 tablet and the Librem 5 smartphone. Whether you are an absolute beginner looking to escape data collection or someone reviving an old computer, Crimson establishes a stable baseline for your computing needs. One of the most frustrating aspects of the modern consumer electronics is the concept of planned obsolescence. Many mainstream technology companies use software updates as a tool to force users into buying new hardware. An operating system update might drop support for older processors, or an application might suddenly refuse to run on a device that is only a few years old. This practice creates massive amounts of electronic waste and forces consumers to spend money on hardware upgrades they do not actually need. PureOS Crimson deliberately rejects this approach. This release is built to fully support the earliest hardware models in its ecosystem, including laptops that were built over a decade ago, such as the original Librem 13 and Librem 15. In the open source world, software is designed to serve the user, which means it must adapt to the hardware you already own, rather than forcing you into a continuous replacement cycle. By keeping the software lightweight and backwards compatible, PureOS ensures that older computers remain completely viable for modern workload. A laptop from several years ago can still serve as a highly secure workstation for web browsing, document creation, email management, and software learning. This approach required disciplined engineering. The developers must optimize modern secure patches and system libraries so they run efficiently on older microarchitectures without slowing down performance. For a beginner, this means you can learn and explore a modern operating system on a machine you already own without needing to invest in expensive hardware upgrades. When an operating system goes through a major development cycle, a significant amount of work happens under the hood to eliminate bugs. A bug is simply an error in the software code that causes unexpected behavior. For beginners, encountering these glitches can be confusing and frustrating. During the stabilization phase of Crimson, developers analyzed extensive feedback from testing cycles to fix everyday annoyances and ensure predictable performance. 3 specific hardware level and system level corrections highlight the stabilization work in this release. A rare but frustrating issue involving system sleep state has been successfully resolved. In older versions of the software, certain computers will enter an unexpected sleep or suspend loop while the user was away, or even during specific background tasks. This glitch was traced to a timing communication error between the Linux kernel's power management system and the desktop interface daemon. The updated configuration ensures that your computer will only enter a power-saving sleep mode when you explicitly tell it to, or when your exact inactivity timeout thresholds are reached. This prevents sudden system lockouts and protects your unsaved work. Modern computing often involves connecting devices to multiple screens, such as plugging a laptop or a tablet into a large desktop monitor or a television. Testing revealed that disconnecting an external monitor from devices like the Librem 11 tablet or Librem 5 smartphone will occasionally trigger a full system crash. The root cause was a software error where the interface tried to read the properties of external monitor even after the cable had been physically pulled out. The display pipeline has been refactored to handle this event safely. Now when you unplug an external screen, your open windows and applications are gracefully shifted back to your primary built-in display without freezing your system or interrupting your workflow. Mobile devices running PureOS feature unique physical hardware kill switches. This allows you to physically cut the electrical power to modules like the camera, microphone and Wi-Fi card for absolute privacy. However, toggling these switches will sometimes confuse the internal sensor that detect how you are holding the device. When a switch was flipped, the accelerometer will occasionally send erratic nonsensical data to the operating system. The software will interpret this as physical movement, causing the screen interface to spin sideways unexpectedly while the device was completely still. To fix this, engineers implement a software filter. Now, when a privacy switch is toggled, the system ignores any temporary noise on the data bus and holds on to the last known valid orientation. The screen remains locked and stable, rotating only when you actually move the device. If you're finding this breakdown helpful, please consider supporting the channel. Don't forget to like, subscribe and ring the bell to stay updated with future videos. Engaging with the channel helps ensure that structured, beginner-friendly educational content remains accessible to everyone who wants to explore open source technology. Let's see how the system handles software structure. If you are transitioning from standard proprietary operating system, the way Linux manages and installs software can seem unfamiliar at first. PureOS organizes its software suites using a concept called meta-packages. Understanding how this works will make managing your new system much easier. A meta-package does not actually contain any software code, applications or binary files of its own. Instead, it serves as a master list or a blueprint composed of specific dependencies. When you choose to install a single meta-package, the package manager reads that list and automatically downloads every individual program, background library and configuration file required to make that feature set functions correctly. In PureOS Crimson, this master list has been completely rebuilt and aligned with Debian Bookworm, one of the most reliable and thoroughly tested foundation in the Linux world. This synchronization updates your entire library system, providing better stability and security patches. The development team customized these meta packages to create distinct versions of the operating system tailored for different use cases. For users who prefer a traditional desktop layout that resembles a standard classic desktop environment, the Plasma version of PureOS has received significant care. To keep the system organized, the Plasma meta package now explicitly installs native KDE utilities like the Dolphin File Manager and Console Terminal, while completely avoiding the installation of non-software pieces. This prevents package clutter in your application menus and ensures that your desktop environment looks, feels and behaves consistently. Additionally, basic development tools are now pre-installed across all desktop images, so you can begin learning compilation and coding immediately. Efficiency is the most critical metric for server environments. In previous editions of the operating system, the Play Mode graphical boot splash screen, the software that displays an animated logo while the computer turns on, was bundled inside the core system meta package. While this logo screen is helpful on a laptop, it is entirely unnecessary on an enterprise server operating headlessly without a monitor attached. It consumes small amounts of memory and can hide important text logs needed for system maintenance. In Crimson, this graphical boot component has been separated from the core foundation and moved strictly into the desktop packages. Server installations now boot up directly into a clean text-only console mode, maximizing performance and keeping the system as lightweight as possible. For beginners, understanding system security can feel overwhelming. Many assume that keeping a computer safe requires installing multiple heavy third-party antivirus programs that slow down performance. In PureOS, security is designed directly into the core foundation of the operating system, protecting you automatically from the moment you turn on the machine. By moving to the new Debian baseline, PureOS Crimson inherits major security advancements that safeguard your data. Binary hardening. The underlying programs in Crimson are built using advanced compiled security flags. This makes it significantly harder for malicious software to exploit common memory errors, creating an automatic layer of defense against security threats. Cryptographic upgrades. The system has updated its encryption protocols while turning off older, weaker methods. This means that your local disk encryption and secure network connection utilize high-entropy cryptographic standards that protect your data from unauthorized access. Service isolation. Background applications are tightly sandboxed using advanced systemd isolation rules. If an individual application encounters an error or is targeted by a network threat, the system confines that application to a closed environment. It cannot access your private files, network sockets, or critical hardware components without explicit permission. This structural security model ensures that you do not need to constantly monitor your system or manage complicated firewall rules to remain secure. The platform protects your privacy and identity by default, letting you focus on learning and using your computer. For users running PureOS on mobile hardware like the Librem 5 smartphone, the camera pipeline has received a massive overhaul. Processing images on a completely open source device is an incredibly complex engineering task. Mainstream smartphones rely on proprietary software layers and hidden locked down firmware blobs to process pictures. PureOS must build this entire imaging pipeline out in the open using clear, transparent software components. The camera system in Crimson received major optimizations that combine hardware workarounds with advanced graphical acceleration to make the experience much smoother for everyday users. The physical rear camera module on this mobile hardware has a known factory-level silicon limitation known as an erratum, catalogued as ERR050384. Under certain recording conditions, the camera data bus could experience a timing glitch, causing the entire viewfinder application to freeze completely and requiring a full device reboot to fix. Because you cannot physically open a chip to repair a manufacturing defect after it is built, software developers created an elegant workaround within the kernel's clock management system. By conducting thorough performance testing, they found that locking the internal camera bus speeds to specific optimized frequencies completely prevents the timing conflict from happening. This fix has been hard-coded into millipixels, the default camera applications, eliminating the freezing issue while keeping frame rates completely stable. The camera interface application itself has been redesigned to be much friendlier and more efficient for daily use. The scanning engine has been updated to recognize QR codes much faster, including difficult situations like read QR codes or items captured in low, uneven lighting. The touch controls on the screen have also been enlarged, making it easy to focus manually when contrast is poor. When recording video clips, a new frame management system keeps the audio track perfectly synchronized with the video frames. This prevents the annoying delay where a person's voice doesn't match the movement of their mouth in long recording. Photos and videos now automatically save with precise orientation data. The file interfaces directly with the device movement sensors, ensuring your media renders in the correct aspect ratio when you share it or view it on an external computer. The most significant change in the imaging stack is how a picture is processed after you tap the shutter button. In older versions, tasks like lens correction, sharpening, and color mapping were handled step by step by the computer's main processor, the CPU. Because the general CPU isn't designed for heavy mathematical matrix tasks, taking a single photo caused high processor usage, delayed shut times, and drained battery life. In Crimson, this entire pipeline has been moved to the graphic process unit, meaning the GPU, using custom OpenGL shaders. When you snap a picture, the raw data is sent directly to the graphics processor as a visual texture. The graphics card processes lens adjustments, sharpens edges, and balances color across hundreds of tiny compute cores simultaneously. This change reduces processing times, keeps the mobile device cool, and produces cleaner images results by leveraging computational power that was too heavy for the main processor to handle alone. To see how the platform has evolved, we can look at this direct comparison between the previous Byzantium branch and the newly released Crimson environment. PureOS Crimson represents an important evolutionary step for open source software, especially for beginners who want a private desktop experience that remains stable, easy to maintain, and respectful of your data. It protects your personal identity automatically, keeps your system running smoothly, and ensures that older computers remain useful tools rather than electronic waste. Even though Crimson has just been deployed, the software journey does not stop here. The engineering team is already shifting focus to the next major phase of development, which will be named PureOS Dawn. Because of the extensive foundation cleanup, package organization, and system modernization completed during the Crimson development cycle, the upcoming transition to the Dawn branch is projected to be much shorter and smoother. Much of the underlying infrastructure built for Crimson directly supports the goals of Dawn, ensuring a predictable path forward for the entire platform. PureOS Crimson stands as a successful validation of what a privacy-focused platform can achieve. Thank you for your time and focus. If you found this video useful, please like, share and subscribe. Thank you for watching, and I'll see you in the next one.